which is known as MasterTMathsclass. And in this live class, we want to solve questions on indices. So we are looking at this interesting topic in mathematics called indices. And for we to be able to solve any questions on indices, there is a need for us to be familiar with the laws of indices. That is, we should know how this law relates together. Like, for instance, let's briefly look at the key ones. That is the laws of indices. Now, let's consider these laws. The first one we have product law. When we have same number with same base multiplying, like a raised to power n times a raised to power n, where a, m, and n are integers. So this can be written as a raised to power n plus n. So that's the first law. So when we are multiplying same base, we can add the index together. Now, also, we have the second one. Division a raised to power n divided by a raised to power n. This is same thing as a raised to power n minus n. So here, when we divide same base, we can subtract their index. Just write one base and subtract. Okay? And also, we have when we have something like a raised to power n, then o raised to power n. This is same thing as a raised to power n times n. This power here multiplies whenever we have something like that. Then also, any number to power 0, a raised to power 0 is equals to 1. Whenever we have a number and that number is raised to power 0, the result is 1. And what also we have negative index. When we have a raised to power minus n, this is equals to 1 over a raised to power n. That is, whenever we have negative index, that's negative, we turn to 1 over. That's like reciprocal of what we have now. Okay? And also, we have fractional index. When we have a raised to power 1 over n, this can be written as nth root of a. Okay? And to generalize that, verse 6, we can have a raised to power m over n. This now will become nth root of a raised to power m. And in this case, it's similar stuff here. Nth root of a raised to power 1. A raised to power 1 is the same thing. Okay? So these are some of the important laws that we should know. And other laws, we also have, whenever we have something like a times b all raised to power n, this can be written as a raised to power n times b raised to power n. This power will affect these two numbers inside. In the same way, when we have a over b all raised to power n, this we have a raised to power n over b raised to power n. You're watching us live at MasterTMathsclass Class. Provincial, you're just joining us for the first time. You are in the right place as far as mathematics is concerned. So don't hesitate to subscribe, be part of this channel, and stay tuned to the end of this class so as for you to gain maximally in this class. Thank you for connecting and have a better experience. Okay? Now, we want to look at some examples to demonstrate all these laws. Let's look at some here. Now, I want to look at some examples. Let's look at number 1. We have 2 raised to power 3 times 2 raised to power 4 divided by 2 raised to power 5. Now, in this question here, we discover that we combine the first two laws of indices. When we handle this one here, up, we apply the first law, which states that a raised to power m times a raised to power n, same thing as a raised to power n plus n. That is, also here we can write it as 2 raised to power 3 plus 4, then over 2 raised to power 5. And here, this becomes 2 raised to power 7, 2 plus 4, 7, then over 2 raised to power 5. This is division. So it's also same thing as 2 raised to power 7 divided by 2 raised to power 5. And which follows the second law that says that when we have a raised to power n divided by a raised to power n, which is a raised to power n minus n. So what we have now becomes 2 raised to power 7 minus 5, which is now 2 square, and which is 4. So we have this as the final answer to the expression we have here. So it's a very interesting application of the law of indices. Then also let's look at the next one, which is number 2. Please help us to share this video and also give it thumbs up. Thank you for doing that. The second question here, we have 81 raised to power 3 over 4. 81 raised to power 3 over 4. Simplify. Now, this here, we can do it in 2 ways. First, we can apply the law that states that when we have the fractional index a raised to power m over n, this same thing as a nth root of a, nth root of a raised to power m, okay, which implies here we can say this is 4th root of 81 raised to power 3. This power, if you like, we can make use of brackets before we put this power. It's the same thing. And 4th root of 81, it implies a number that multiplies itself 4 times. That will give us 81. That's 3. So 3 raised to power 3. And also 3 raised to power 3, that's 27. So it means that here, 27 is final answer to this. Or we can decide to rewrite this 81 here and say 81 is 3 raised to power 4, which is now power 3 over 4. Then applying the third law that we have, that whenever we have a raised to power n, then raised to power n is same thing as a raised to power n times n. In the same way here, this power multiplies. That is, we can say that this becomes 3 raised to power 4 times 3 over 4. And when something like this multiply, 4 here cancel each other, and this becomes 3 raised to power 3, which is also 27. So this is same thing. Whichever one we use, we are still correct. So thank you for staying tuned. Do well to watch to the end so as to enjoy this class the more. So let's look at the next one, which is number 3 here. Also, we have simplify 16 raised to power x, 16x raised to power 4, then is y raised to power 8, then all raised to power 1/4. So now we want to simplify this. This power here will affect each of these number. Don't forget from when we have a times b all raised to power n, we say this is a raised to power n, then b raised to power n. So this power will affect the number. So x power 1/4 will affect all the numbers we have here. It will affect 16. It will affect x raised to power 4. It will also affect y raised to power 8. That is, this becomes 16 raised to power 1/4 times x raised to power 4 and times 1/4. Then also times y raised to power 8 times 1/4. So we have used this power now on these three numbers inside. And then next step here, we can say that this will now be equals to 16. Of course, this is 4 root of 16, which is also 2 raised to power 4 raised to power 1/4, if you like. 2 raised to power 4 is 16. And here, this power cancels each other. We have x left, they multiply. And also here, this power also multiplies, so we can say 2 here, 4 here, 1, and 4 here, 2. And we have y squared. And similarly here, we have 4 here, 4 here, cancel each other. We have 2 left. Because 2 raised to power 1 is still 2. Then we have x, then y squared. So here we have this as the final answer to what we have here. So it's very important you understand this law of indices works. Okay? So that's the number 3 question. Okay? Now, let's look at the next one here, which also serves as the number 4. So we are going to like number 10. So ensure you watch the end. We have some interesting question here. Okay? That's you will not like to miss. Okay, now number 4. Let's have a raised to power minus 2 equals to 25. Now solve for a. This is an equation now. When in mathematics, when you have equation, you are going to have equality sign and you have the left hand side and the right hand side. Now the unknown here is a, which we are finding. And if we want to solve this now, okay, our goal is to find a. So we can decide to remove this power, which is minus 2. So that's the best way to go, with this easily. And how do we remove minus 2? Now, if you have minus 2, the inverse of minus 2 is 1 over minus 2. Why? Because minus 2 cancel minus 2. This one will give us 1. Inverse of a number is under the operation of multiplication. It must give us the identity. Identity under multiplication is 1. Okay? So, we are talking about the inverse now, which is 1 over minus 2. So, use that to multiply the power on both sides. So, what I'm saying now, we have a raised to power minus 2 times 1 over minus 2. 1 over minus 2 actually is same thing as when you have 1 over minus 2. The same thing as minus 1 over 2. So, it's same thing like that. Then equals to 25 raised to power minus 1 over 2. We can still write it like that, which make this one now to cancel each other. So a left here, and we have this now remain 25 raised to power minus half. Then we can put this in a proper way from the same law of indices. We have one of the law, like in our law we stated like number 5. If you scroll back, you can check from the beginning, like number 5 or so, we say negative index. When we have a raised to power minus n, this is same thing as 1 over a raised to power n. So it is this negative that turns to 1 over. So now, if I want to write this again, I can say this is a equals to 25. Sorry, I have 1 over 25 raised to power half now. Okay, so this now it can become 1 over 25, also fractional index. This is square root of 25 easily. Square root of 25, which is now 1 over 5. So that is that about that. So therefore, a here equals to 1 over 5. That's the final answer here to this particular problem. So it depends on the understanding of the interpretation of the problem we're solving. So just make sure that you are following the law. So without knowing these laws, it may not be easy for us to handle problem under it. So that's why for us to be able to solve questions under any topic in mathematics, like this topic now, indices, you must first master those laws so that whenever we see something related to it, we'll be able to use it there. Okay, so next, number 5, let's look at another one. And this question number 5, the questions we have to simplify 27 over 8 all raised to power 2 over 3. Okay, easily now I can use this method of fractional index. Fractional index a raised to power n over n is same thing as n root of a raised to power m. Okay, so use this now, and this becomes cube root of 27 over 8 all raised to power 2. Then cube root of 27, that's 3. Cube root of 8, that's 2, all raised to power 2. And here, 2 affects 3 and 2. From that law that say a over b, all raised to power n. Same thing as a raised to power n over b raised to power n. And this is 3 square over 2 square, which is 9 over 4. So that's what we have as the final answer. Or if you don't want to do it that way, we can say that 27, that's same thing as 3 raised to power 3 over 8, that's 2 raised to power 3, then all raised to power 2 over 3. And also, from the law of, it is the same thing when we have a raised to power n over b raised to power n. This is same thing as a over b, all raised to power n. That is, here we can say this is 3 over 2, all raised to power 3. Now, raised to power 2 over 3. And don't forget here that this power also multiplies on the law of indices. And we have 3 over 2 raised to power 3 times 2 over 3. Okay? And 3 cancel each other. And we have 3 over 2 all square, which has led us to this place, and which is now 9 over 4. So that is that. Whichever one that comes to our mind, we can use it whenever we are solving problem. Okay, I believe you are enjoying this class. Don't forget, please give a thumbs up to show that you are enjoying this class, and also give your comment and share this video. God bless you. Now, yeah, stay tuned to the end. We are in number 5, so and I want to look at 10. So let's look at number 6 now. Let's look at number 6. And this is a simple equation as well on indices. We have 5 raised to power x equals to 125. So solve for x. Solve for x. Now, this equation now, we can make the right-hand side also to be in base 5. That is 125 can be written as 5 raised to power 3. That is 5 multiply itself 3 times. So this equation here now becomes 5 raised to power x equals to 5 raised to power 3. And this is direct answer now, following just a law of indices that states that a raised to power m equals to a raised to power n. Here m is equals to n. Y, same base. We equate the power. And here we have x equals to 3. That's our final answer. So that is it. Okay. Now, also number 7. Let's look at number 7. Yeah. And this, here we have 4x squared y is power minus 3. Then all raised to power minus 2. Now simplify. This number 7. Simplify. Okay. This power of minus 2 here is affecting all this number here, just like on the law that we have a, b, all raised to power n. This is same thing as a raised to power n, b raised to power n. So minus 2 here will affect 4. We affect x squared, we affect y raised to power minus 3. That is, here we can say this is 4 raised to power minus 2. Then x squared raised to power minus 2. Then y raised to power minus 3 raised to power minus 2. Then this now becomes, here we follow the negative index. That is, we can say this is 1 over 4 square. Then this power multiplies. And we have x raised to power minus 4. Also this multiply. And don't forget, minus times minus turn to plus. So this becomes y raised to power 6 now. 2 times 3. And in other words, we can write it as 1 over 4 squared, that's 16. Then x raised to power minus 4, y raised to power 6. And if also we want it another way, this is also negative index. And we can also write it as 1 over. So which means we have 1 over 16 times 1 over x raised to power 4 times y raised to power 6. And when we put it properly, you can say this is y raised to power 6 over 16x raised to power 4. So here we have the final answer to the given problem. Okay? Now, let's look at number 8. Yeah. For this class. This is also a simple equation on indices. It's a simple equation. And the question says, solve 3 raised to power x equals to 81. Now, the unknown here is x. And also, when you look at the right hand side, is a number that we can express in base 3. That is 81 can be written as 3 raised to power 4, which means 3 multiply itself 4 times. In other words, this equation now becomes 3 raised to power x equals to 3 raised to power 4. Okay? Now, directly, the answer is known. Why? A raised to power m equals to a raised to power n. M is equals to n. Same base as well. So, x equals to 4. And that's the final answer to number 8 question. Okay? Then, number 9. Also, we want to simplify this given expression. It's also an interesting one. Okay? So, we have 9 times x raised to power 6, x raised to power 6, y raised to power 3, then all raised to power 1 over 2. Okay? Now, in the same way, 1 over 2 here will affect 9, x raised to power 6, y raised to power 3. Then what we have here becomes 9 raised to power half, then x raised to power 6 times 1 over 2, then y raised to power 3 also times 1 over 2. Then when we simplify here, n raised to power half, square root of 9, the fractional index. Then here, this power multiplies 2 here 1 and 2 here 3. So we have x raised to power 3, and here can be written as y raised to power 3 over 2. Okay? And finally, square root of 9, that's 3. And this becomes x raised to power 3, y raised to power 3 over 2. And this is the final answer. Okay? So I believe you are enjoying this class. This is MasterTMathsclass. So do well to subscribe if you are new in this channel. This is the right place for mathematics. You are going to enjoy solving math here. So this is the right place for you. Also give a thumbs up and share this video. And thank you for doing that. Now, let's look at number 10 now. From what we have also simplify is interesting one. You don't want to miss it. 2 raised to power x minus 3 times y square over 4 times x raised to power minus 1, then times y raised to power minus 2. Okay? Now, let's solve this now. And what we have up here, everything here is square. Okay? And let us forget that. Everything there is square. Now, solving what we have up first. Don't forget, these two here will affect all the number inside, just like when we have a, b, 4 raised to power n. This is a raised to power n, b raised to power n. So 2 here will affect each of these. And it is 3 numbers we have here. 2, x raised to power minus 3, y raised to power 2. So we have 2 square. Okay? X raised to power minus 3 also times 2. And y raised to power 2 also times 2. Then over, we still have this as 4. X raised to power minus 1. Y raised to power minus 2. Then up there, 2 squared, that's 4. Then we have, this becomes x raised to power minus 3 times 2 minus 6. Then y raised to power 2 times 2, 4. Then all over 4. times x raised to the power minus 1, then y raised to the power minus 2. Okay? Then here, these 4 has cancelled each other. Now, this is division. Here we have same base. We don't have to waste our time. When we have a raised to the power n over a raised to the power n, this is a raised to the power n minus n. Why? This is division. When same base divide, we can subtract the power. So here, we can say that we have x raised to the power minus 6 minus 1. So it's minus, and we still have minus 1. Then we also have y raised to the power 4 minus 2. So that is that. And mathematically, minus times minus, when you have minus minus, it's minus times minus. And minus times minus is plus. So it means you have minus 6 plus 1. And minus 6 plus 1, we know that that will be minus 5. So this is crucial as far as mathematics is concerned. That is where the foundation of mathematics is. See some students battling with directed number, adding negative and positive number. So that's why in the foundational class, the student should be able to handle this kind of thing without stress, so that it won't give them problem when solving math problem later on. So here, this will now become x raised to the power minus 5. Then y raised to the power, this is plus now, 4 plus 2, that's 6. So here we have the final answer to this given problem. And that is that for that. So we have solved 10 examples on this. And we can have so many on the law of images. So you can go on, textbooks, internet, solve as many as possible. If you have any problem, reach out to us and we look at it together. Until when next we meet, stay tuned and stay blessed. Bye for now.